Welcome to 5-Minute School. In today's video we're going to be talking about aldosterone and sodium-potassium balance. So aldosterone is a mineral corticoid or a steroid hormone which is produced by the adrenal cortex, and it regulates the renal absorption of sodium ions and the secretion of potassium. On the left hand side here we've got a diagram of a nephron. This is the Bowman's capsule or the glomerulus, and blood is going to get filtered through this Bowman's capsule to form filtrate. This filtrate is going to contain quite a lot of useful molecules, ions, which the body wants to preserve. In this video we're focusing on the ions sodium and potassium, so we'll talk about how they are reabsorbed or secreted. So majority or 90% of the filtered sodium and potassium is going to get reabsorbed in the early part of the nephron. And this reabsorption is going to occur itself. It's going to happen independently. It doesn't require hormonal regulation up until this point here. So in the early regions it's going to happen independently. Now the final concentration of sodium and potassium in the urine is going to depend on whether the body either requires higher or lesser amounts of these ions. So the final concentration of sodium and potassium in the urine depends on processes which occur in the distal convoluted tubule and the cortical part of the collecting duct. So that's these regions here, and these processes are regulated by the hormone aldosterone. So first we're going to talk about the reabsorption of sodium, then we'll look at the secretion of potassium. So even though 90% of the sodium is going to be reabsorbed, there's still quite a high amount left in the filtrate. So without aldosterone, even 80% of this remaining amount is still going to be reabsorbed through the wall of the tubule into the peritubular capillaries. So this is going to be 8% of the amount that's filtered. So 98% is initially going to be reabsorbed and 2% would be excreted. So when we have aldosterone, which is secreted in its maximal amounts, all of the sodium ions are going to be reabsorbed. So 100% would be reabsorbed. Aldosterone stimulates sodium reabsorption to some degree in the late distal convoluted tubule, but its primary site of action is the cortical collecting ducts. So the primary action of aldosterone is in this region here of the nephron. Now we're going to talk about potassium secretion. So 90% of the filtered potassium is going to be reabsorbed mainly from the proximal tubule. And for potassium to appear in the urine, it must be secreted into the later regions of the nephron. For example, the cortical region of the collecting duct. Now, secretion of potassium into the late distal convoluted tubule and the cortical collecting duct matches the amount of potassium ingested in the diet, so the blood potassium concentration remains in the normal range. So after eating a high potassium meal, the rise in the blood levels of potassium would stimulate the adrenal cortex to secrete more aldosterone, and then aldosterone itself would stimulate the increase in the secretion of potassium into the filtrate. So that's known as aldosterone dependent potassium secretion. We also have aldosterone independent potassium secretion, where a rise in blood potassium directly causes potassium channels to become inserted into the membrane of the cortical collecting duct. Now, just some last few points in regards to this. As sodium is reabsorbed in the distal convoluted tubule and the cortical collecting duct, there's an increase in secretion of potassium into the filtrate. So as sodium is reabsorbed, there's going to be secretion of potassium into the filtrate. And this is a result of a potential difference which is created by sodium reabsorption, which makes the lumen negatively charged compared to the basolateral side. So if we're having reabsorption of sodium, it makes the lumen negatively charged because positive ions have been removed. So to counteract this, potassium ions are going to enter into the filtrate because potassium ions are positively charged, so they're going to pass into the filtrate through specific channel proteins. Now, because potassium secretion is increased when there is an increased sodium reabsorption, a rise in sodium content of the filtrate reaching the distal tubule will cause an increase in potassium secretion.